This is an example of a logarithmic equation because if we look for the x, which we're trying to solve, it's inside of a log. So whereas our exponential equations, you know how you took all of your log formulas and you expanded, and that's what helped you solve them? For a logarithmic equation, you're going to have to do the opposite. You're going to have to simplify. In fact, your main goal is to write as a single logarithm. And so if we can take this and write it as a single logarithm, so that's our main goal, then we can use our definition of a logarithm and change it back to exponential form. So what does that look like? So we have sort of two main things. We've got our main goal. The main goal is to write it as a single logarithm. The reason we want to write it as a single logarithm is because then we can apply our definition of what a logarithm is and change it to exponential form. And you've solved some simple log equations already that were already single logarithms. So in this example, we're trying to solve this. We got log 3 of 9x plus log 3 of x equals 4. I have a log law that says if I have a log plus a log, I can simplify that and write that as a single logarithm. How do I do that? What would be inside of here? 9x squared, because you would multiply those. So adding two logs is like multiplying inside. That's our very first log law. We have the right-hand side where it was log of m plus log of n, so you can write that together as log of m times n. So I just took 9x and multiplied it by x and got 9x squared. You could write that without the brackets as well. I just put the brackets there. Now we have a single logarithm. That was our main goal. Once you've got your main goal, then you can use your definition of what a logarithm is and write it in exponential form. What's the base? What's the exponent? And the answer is 9x squared. And so what we've done is we've now changed it to a type of equation where the x is no longer inside the logarithm, and you can solve for this. 3 to the 4 is 81. Divide both sides by 9. Square root both sides, and you get plus or minus 3. Now, one added thing that you always have to do with solving a logarithmic equation is you have to check your answer for answers that appear but actually don't work. And we call those extraneous roots. You remember seeing that word before? So an extraneous root in math is when you get an answer algebraically, but when you check that answer, it actually doesn't work. So what is the main thing that was going to cause us a problem is you can't have the log of a negative number. Right? If you think about any log graph looks like this, right? With an asymptote right there at 0. Log graphs do not exist when x is less than 0 or when x is equal to 0. So when I'm thinking about these two answers that I have, one of them is x equals negative 3, the other one is x equals 3. As far as checking for extraneous roots, I'm not checking to see if simplified it works out perfectly. I'm just checking to see if I plug in -3 into my original equation, would I ever take the log of a negative number? So check out the first one. If you plug in -3 for x, can you see that 9 times -3 would be -27? And then you would have log 3 of -27. You can't take the log of a negative number based on our graph and based on what we know about logarithms. So this one is an extraneous root. Our second example, 3. Put 3 into the first one, you get log 3 of 27. No problem. Put 3 into the second one, log 3 of 3. No problem. As long as you're not taking log of a negative number, you don't have to plug it in and figure out perfectly if it works. You don't have to verify that the left side is equal to the right side. All you need to make sure is that you're not taking the log of a negative number, and then you're fine. So the key thing here, in all log equations, you're going to use this idea. I want to get it as a single log because then I can change it to exponential form. And for whatever reason, that is hard to remember. Solving log equations, those two steps are very important, but for whatever reason, they're hard to remember. So you get it as a single logarithm so you can change it to exponential form because whatever's inside your logarithm becomes your answer, and then you've got x in a form that you'll be able to solve. So I'd like you to try 3, 4, and 9.